Alright, so we're talking about dualistic corpuscular time shared spaces, particle reunitizing reality makers, and that's a black hole. So now we've got this would be the trajectories of a particle are, and I'm going to say it in a way that I've devised, which is easier for now. Is potential particle is space-time, and V particle or virtual particle is superposition time, and they're out of phase time, out of phase dualistic times, corpuscular times, separate but intimately connected in a black hole. So the time, the V particle is perpendicular to the P particle, and when they have a coincidence or a cooperation, a particle forms. So this is the space, this is Earth, or your point of view, and then this is how far you can see within that space. Now this isn't a literal diagram, it's a conceptual one. And and then here you notice it's got like the singularity's path. Well, literally, the particle, from its own point of view, it thinks it's moving through the singularity, but from the singularity's point of view, it's trapped in the center, and space is what's moving around the particle rather than the particle moving through the singularity around the attractor in the center of the singularity. It's actually trapped by the attractor of the singularity. So, but the particle is just oblivious to that, because all particles are in the center from their own point of view, an extended form of special relativity or general relativity. I like it. The special theory of relativity. It's an extended form of it. So like classical physics, general relativity, and special relativity work up to the edge, right up to the edge of the black hole, up to the event horizon. After the event horizon, then you have, so in this reality you have two corpuscular times. One is superposition time and the other one is space-time. So in the black hole you have the same thing. So at the beginning, again, there was a Big Bang, and we never left the Big Bang, because you can't escape a singularity. So we never left it. And inflation is basically those few moments when all the space is developed inside the black hole. And it's been equated to a balloon. It's a very good analogy, because it just fills it up, and two spaces within there would get wider, and those particles that the base particle is in my model I say it's a Planck length, and then inside there it would look like this, like a cube. Not literally, but for our conceptually, the update would be at every part of that. I call that the core. So now every point in the space particle, or if you take all of space basically, and you go to one individual spot, you'll find that it's a quantum job of canceling all gravity except for the weak force. Meaning that since every point has all these arrows facing inward, and right next to it it's again and again and again and again at every point, if you draw that out, it creates a cancellation. And I talked about that in a previous video. Again, that's light's max reach. That's as far as you can see from the middle. From every point in the universe, or our space-time, it would look just like this from wherever you are. And because the center is where you're held, if you're out farther, it would create an optical illusion of expansion. And there's another physicist that talks about this in detail and is not. He's got some interesting proofs. I'll go over that later when I look him back up and quote who he is. And I just ran across it one time and I realized it matched my model. Okay, so under this method, it doesn't matter where you are. You're stuck right there. Two particles are still stuck. Billions of particles are still all in the middle. The planet is in the middle. The sun is still in the middle. And it is beautiful, nearly perfect symmetry is what I wrote there. This is just a diagram, but in reality there is no edge to space. It might be that the event horizon is repulsive from the outside, meaning there could be closed-door singularities that wouldn't let anything in. This could help explain, possibly help to explain some gravitational lensing effects. And then that's the core. And then in there'd be a certain area where you could only see so far, because of the limit of being able to see distantly. In our universe, we can only see so far, and then as you go forward, basically from the point of view of one item, you would just keep going and going and going, and it's as if you're going down a hallway. I've said this before in some of the other videos, but if you just watch this video, I want to say it here too, that the bricks behind you are building the hallway in front of you. So, matter of fact, in this particular reality, it would be in any direction and at the same time. It doesn't matter. It doesn't care. And that's the unique nature of space. Let's see. 3 space-time realities with 6 corpuscular times. Each reality has time and supertime, which is superposition time. And here's a matrix with a black hole forming another matrix and that has a black hole that forms another matrix, and they're all, because in our universe formed from a black hole, and then we have black holes in ours, that creates another time shared space, and then in there could be another one that creates another time shared space, etc. and so forth. All these spaces have a unique corpuscular time, and the black holes all have unique corpuscular supertimes named after superposition, because this is what it is. The black hole... the black hole is excluded except for the gravitational force from that space, and a new quantified space-time emerges. All of these together form the universe. General relativity works in each of these corpuscular times. It's just reunitized. Space-times reunitize space-times, but in the black hole and the canceling process will be called quantum gravity. So that's quantum gravity is I don't know if I was really saying that right, but each Planck point would be captured. Right, one Planck point over, that's captured. So those you'd take arrows in all directions pointing to the center, and since if you draw them out in a cube like that, you'll notice that those arrows cancel each other, except for in less than the Planck length would leak through. And so there's basically, it doesn't mean what I'm saying is literally correct, but it means it's a conceptual beginning to start from. Okay. Let's see, the pressure from the black hole changes light's diameter in relationship to where it came from. And this rips it from that time to a new unitized space-time. Skipping the detailed explanation, the particles, the planet, the sun can move anywhere within this lattice, and millions of suns can move in the lattice in any direction, and still remain in the center from its own point of view. It's an extended form of relativity. And the black hole doesn't care, because it's still, as far as it's concerned, has everything captured it wants captured. Here's a little, let's see, finally a view of quantum gravity. So when you're jumping on Earth and you go up and then you pull back down, you're actually falling to the center of a singularity. It's the attractor of the singularity. And if you're jumping on the moon, it's the same thing. And because you're in space, which is, I call it the space particle. But the space particle is also, from its own point of view, divided up into little particles that are also trapped and captured by this singularity, canceling the destructive form of gravity. If you're here, you've already been through the destructive part and ripped down to the basic components. But once you're here, then you can assemble. We know this happened. I'm not going by what I think. I'm going by what we know, because we know that happened due to the work that's been done by many scientists before. So, let's see, all gravity is cancelled except for that of a mass particle cumulative. All particles are falling to the center of the black hole, so two particles join in that. A black hole, you have a gravitational field, you have space, you have the core. So here, got a nice little diagram there. You know, these trajectories are particles that believe they're traveling through space. The update process occurs in the core. From every point of view of every particle, it's in the center. You have space, that's part of that. You have the core, that's in there. You have the middle, from every point of view, the middle. And you'll notice that this is exactly what Einstein was talking about when he was talking about perspective, points of view, you know. And this is just another it's an extended version of the same thing, except that it goes, Einstein's version goes up to the edge of the event horizon, and then in the event, once you go past the event horizon, you have a whole new set of the classical physics is in there. And but there's a dual corpuscular time in there. You've got your space time, and then you've got your superposition time. Coincidentally, let's see, no, you have light limited discernment from the middle, so you can only see so far. The middle can see no farther. And anywhere within it, you cannot see out of this whole process. You can't see past that certain point. That's that little diagram there, which is here and on that other page. Limited viewing distance creates almost a perfect core. I mean, it really is amazing. And the reason why I say that the core is actually quite flat is because if you imagine in your mind that gravity well, we know conceptually it's very long. It's actually more likely to just be a singularity with multiple particles stacked and space particles stacked, and and then the update process is just one trajectory, and it updates and one update here would be one Planck time would be a complete update from the super time. So time in this aspect under this model is built one from our perspective, one Planck time at a time. Within that realm, you might say, it's ironic, it's Planck, you could say brick. So one little tiny brick at a time, it's all built. A singularity will create a new core outside of this space-time. These slices of space give us frames. Frames can explain the double slit and spooky action at a distance. So you have an extended version of relativity. I call it quantum relativity. Space has a limited volume, being infinitely divisible. Means it must have a limit, and that limit is a quantum jump that fixes that trap of eternally dividing space. So whether you look at it from the point of view if the update occurs from one particle to the next serially, or if it occurs like in a if it's indivisible, if it's infinitely divided, the gravity well would continue infinitely. Seems to me is that's a problem. So that's why I say that it's a Planck length, because that creates a limited length. And if it is it just seems like a good place to start. So the no mass particles or energy particles move through the core, and the potential mass particles collide at 90-degree difference, causing a particle to form. If this collision is consistent, then the particle has permanence. The core could be the Higgs field, or involved with the Higgs field. So when the thickness of a wall is smaller than the longest possible quantum jump, tunneling may occur. Just see my time. Okay. If you had a very thin entangled foil that is one molecule or a couple molecules thick, or one it'd have to be several molecules thick, then pull them apart, and if they were entangled, launch a single particle into the entangled wall, will the other particles still jump through? Like if you separated them and these two walls were entangled, would it jump through that gap? What if they stay entangled? Information transfer faster than light information transfer through quantum tunneling. I'm not saying this is possible, I just thought of that and wrote it down. It may be that if you entangle two pieces of diamond, I did find some experiments that were on diamond pieces. They were very interesting, actually. I wrote this before I even knew about it. But basically it's just talking about entanglement. It was quite complicated, actually. What if you put two entangled particles into the same neutral substance, keeping them entangled because the substance locks that entanglement? We wish. Each complete cycle within the core is the smallest moment of time in the core. In other words, passage of time. This cycle sets the passage of time. This is time. Each cycle is one passage of time, although supertime might be called all time, which can't be because of a halting problem. Not infinite. There is an infinite, but it is curbed to make it work properly. Centrifugal force pulls a singularity out of space, and it breaks free into a new corpuscular time. Can a black hole be severed from our space, its original source space? That was just a question I was asking myself. And I was just looking at this. It was mentioning some stuff that I don't. Oh yeah, I don't want to go over that. There are no gravitons. I think there are gravitons, but we go into what that is later. Matter of fact, I think I'm still even working on part of that. But even without gravitons, we can know intimately more of how it works, as I have already described, and I believe that is a really good. I think it's a good fit and a good model. It explains many things. There's some things that it may not fit with, but most of those things that it doesn't fit with seem to be problematic anyway. Say like, if I'm not mistaken, like Mond is basically a tool that looks at what's happening and creates a correction for what we see versus what is. And that's not really a science in the sense, it's like saying we're going to create a system that corrects our aired mathematics with a visualized measurement that causes a correction in the math or something. Anyway, I wasn't very impressed with Mond, but it's a good way to create a correction tool to actually calculate what is there versus knowing what's actually happening. The only graviton is a singularity. I'm going to say some things that that are just throwing them out there, because most of this stuff we can't even see. We have to you have to figure out, insinuate, use other testing to imply what's actually happening. The core's nature provides quantum fluctuations. Empty space is empty, but a particle can pop into existence and pop out of existence. This comes from non-persistent updates. Collision between virtual particles are non-consistent directions, like a couple pieces of light traveling from several pieces of light traveling from several different suns could collide for a while and then create a particle, and then it could just snap out of existence just from the coincidental interaction. It's rare, but it could happen. And looks like faster something goes, the less updates it gets. And at near light speed, almost no updates. At light speed, no updates. And light doesn't age. This is the away from center speed. So the faster you go, the less updates you get. If you get no updates or beyond that, you actually fall through like an event horizon at that point. So, and there's several reasons why that can happen. But some of them are real and some of them might be just a thought experiment. Let's say part of the particle is captured by the singularity, and if it hits the opposing force of the zero diameter of the particle, it captures particle's components and makes the particle according to the rules. So I think I was describing let me see if I can figure this out. The expanded frame, original particle captured tiny singularity. Oh, I don't know. I think that was an attempt in I don't get it, that particular thing I wrote. I write these things down, and sometimes you're tired, sometimes it's early in the morning and you're not tired, and sometimes it's just whenever you feel inspired to write something down. And sometimes you gotta sort your stuff out. Now I could have gone over this stuff for years, but I'm trying to get something released because I think it's important, and I think time is essential for these things. So I'm trying to release something earlier than many years later or something like that. Let's see. Yeah, so basically I think I was starting to talk about, at this point it makes you wonder, are all particle singularities tiny singularities? I don't know, could be. But wouldn't each singularity become one singularity, or do singularities keep their own indivisibility? This would mean, now I know that a lot of people will say, well, no, we already know that particles aren't singularities. Well, if they're not singulars, they're definitely powered by singularity, the main singularity, the black hole that we never left. And that basically means that the particles that were captured, if you look at it like a light particle that's captured or something else, that if the particle's energy was released, it would travel in straight lines instead of little circles that create the atoms that everything's created out of. So, like I had discussed earlier, it's almost as if like falling into the black hole is kind of like falling in the bottom of a pool with the cover over it and you can't get out. So the particles are trapped by the gravitational well of the singularity, but because of space unique property, they gain an independence within that cancelified space, and they gain degrees of independence where they can go in any direction. Doesn't matter. The black hole still has them captured. It doesn't care. This would mean that the singularities. Let's say. Wait a minute. Oh, like if a particle goes into singularity, why doesn't it just become part of the singularity? Like, or why doesn't it vanish? Like, if it was to vanish or get crushed down to nothing, it would the gravitational force just be gone after that, So, but then again, if you take a planet, as it's being crushed, it starts to spin faster, and as it spins faster, there's more centrifugal force, and that would fight back against the centripetal force of the black hole, and eventually an equilibrium would be established. But if the source of the singularity was the black hole, then that wouldn't explain why the particle can fight back with its centripetal force. So there definitely has to be like a closed door singularity of some kind. And then if you did have a closed door singularity, I'm not sure about big ones, but tiny ones, it would be possible that they would just not interact unless it was the right substance. If it was the right thing and they had key matches, they could cling together. And this could be why atoms have these bonds that are like unbreakable. You'd be experiencing time dilations, and it would explain a lot of the uneven integers of energy, that if you actually get some of the electrons to break free that aren't really supposed to, then that would explain it, changing into something else, emitting tons more energy, radiation. The probability of the wave function is an orbital affected by close proximity particles that are within the frame on the core. All matter seems to be in sync, or the image. Okay, so in a interference pattern, all matter seems to be in sync, or the image would just be fuzzy. In the case of light, yes, it seems. Yes, it still is interference, but of a solid is acting like light, like gold. Or like anything solid. I think they've tried it with gold particles, and it still creates an interference pattern. Why is gold acting like light? And that's because it's a trajectory. The trajectories are the solid opaque material of the narrow slit is actually affecting the either whether it's light or a molecule. The cycle is actually changing the trajectory of the light as far as which, if it's in a, let's say in the case of light, and there's two slits, determining which slit it went through in this fashion is it goes through both, because the trajectory is of such where it oscillates between two frames of reference, but the two frames of reference here can be apart, and in this superposition they can still be entangled or near or together, as you can see from the matrix that I was showing you earlier. When you have a trajectory going around and there's two particles updating a certain spot, or if you have in this case you have one particle going between two frames of reference, it's either going to hit one frame or the other. So at a superposition time, that is, from that point of view within superposition, you'd just be seeing an orbital on oscillating between two paths. So when